All right, good morning, good afternoon, or good evening. Welcome back. We are in part two of our video series from today. Part one, we configured DHCP, and in that video, I gave the wrong acronym for DHCP. I believe I said it was Dynamic Host Control Protocol, but it is Configuration Protocol, the Dynamic Host Configuration Protocol. Uh, Nonetheless, today we are doing DNS, which is Domain Name System. I'll go ahead and give us the objective here. We are building one from that video, so we already have our topology set up within Packet Tracer. Our objective for this video, though, is to showcase how DNS protocol resolves domain names to IP addresses. This project configures a DNS server and connects end devices to validate proper name to IP resolution. And the goal is to demonstrate how DNS simplifies network navigation, improves user accessibility, and ensures reliable communication across the network. So what we'll do first here is label all of our end devices with their IPs so that once we head into the server, we know the proper names and the IPs for the DNS configuration. To do that, we'll just go ahead and hover over a specific end device. Excuse me, we'll start with the laptop here. As you can see, as this text box pops up, our IP address for laptop 1 is 192.168.10.3. So we're going to give this a name and then also label it with its IP address. For here, we'll go with tried. And then the IP, excuse me, is going to be 192.168.10.3. We'll do the same with our other devices here. For the printer, it is 10.4, so we'll go ahead and label that as well. Alrighty, for laptop, this is laptop 0. That IP is 10.2. We'll do true 192.168.10.2. And we'll do one for the PC as well, which is 10.6. So 192.168.10.6. And why not? Let's go ahead and give the switch an IP as well first. We'll say this is Topanga's computer. And the switch has 10.5 as its IP. All of these IP addresses were assigned through DHCP in our previous video, so go and check that out if you would like to see how you can dynamically assign IP addresses instead of statically going into each device and assigning them an IP. So this is switch. Excuse me, 192.168.10.5. All right, so we have each one labeled, and DNS is fairly simple. What we'll do is head on into the server. We'll head over to services. We've already configured DHCP here with our pool name LAN, and now we'll head to DNS. And what we're simply going to do is copy the same information that we labeled with. So we'll start with PC0. The name is Topanga. The IP address is 192.168.10.6. And we can simply do add, and then we'll do the rest for the rest of our end devices here. Oh, excuse me, I put the IP in the name section. Let's just go ahead and copy and paste that down there. And that is for the switch. All right, we have the switch added. Let's go ahead and take care of laptop 0. That's True's laptop. We'll type in the name, true, and add the IP address. Click the add button here. Let's slide me down just a bit so that we can see without an issue. Printer is next. And I see I added an extra 1 in that IP address. Might have fat fingered that, but not a problem. And lastly, Tried's laptop. All right, that's been added. I do want to fix this. All right. So we do need to make sure that we turn our DNS service on as well. Go ahead and turn that on. And so what I want to first demonstrate is pinging another end device using the IP address. We'll go from Topanga's PC to Tried's laptop. We're going to ping this IP. So we'll head on in to desktop, and then we'll head to command prompt. We can do a ping command, and that's 192.168.10.3. So when we're pinging, we see that we do get a reply, a success rate of 100%. But using DNS, we will not have to type out that full IP address. Now, what we can do is just use the name. So we just pinged 10.3, which is Tried's laptop. But now what we can do is type in ping and simply type in Tried. And we see we're getting a reply there. We can do the same since we named printer. So we can do another ping command and just do printer. And we're getting replies. And so I do want to show what this looks like in simulation mode as well. So since DNS has already taken place, what we need to do, just so I can reset everything, is I'm going to clear the cache. So it's going to be as if we never sent those packets out. Righty. So I'm just going to head right back in to Topanga's computer. We'll head to the command prompt. And this time we are going to ping. Let's ping true, which is laptop 0 with the IP 192.168.10.2. So I want to type that in first. Ping, we'll just type in true. Slide that up a bit so you can see it. So we have ping and true here. I'm going to slide me back to the top, head to simulation mode, and we'll run that command. So once we run that ping, we see it starts here at PC0. We can play. That packet is going to head up to the switch. Next, it's going to head to our server and then back down to that switch. It heads to the server so they can identify exactly where to send that packet. It's going to send it back to Topanga's computer saying, hey, if you're trying to reach true, this is the IP address. Topanga's computer sends it back up to the switch, and now it will send it out to find where's true. It's going to be right here. True has been identified. That packet will be sent back up to the switch and then down back to PC0. So that's that ping command. We're reaching out to the switch, who then in turn heads to the server since that's where DNS is configured. And it gets that information on where to send that information. And it's that same process for all of these end devices here. That ping command is a really good command to test this out. And of course, simulation mode I love because it gives you a visual of exactly how the packets are being transferred. So, like I stated, DNS is pretty essential for network engineering. There's different flavors to DNS as well. We have different key protocols through DNS that we need to be familiar with, such as DNS SEC, which is for domain name system security extensions. And then we also have DNS over HTTPS, which is a protocol that encrypts the queries and responses coming from the network so that third parties aren't able to snoop or block or interfere with any of the information that you're trying to gather while using HTTPS. So definitely a security protocol, but one that's just necessary to be familiar with. It's impossible to memorize all of the protocols throughout network engineering, but you should be familiar with them or the acronyms, just so you have an understanding of what you're working on. But yeah, that's our video here for today. Don't want to go on too long. I want to thank you guys for joining me in part one if you did, and thank you for tuning into part two. It was a lot of fun configuring that, the DNS and the DHCP, and I'll catch you guys in the next video. Looking forward to it. Have a good one.